Okay, I've just got the machine set up with a new dust shoe, and swing it right over here, you can see it. It's a very simple 3D printed thingy with a detachable mount for the hose, so I can change it if I decide to go for a wider hose. Clamped onto the spindle itself, and then the dust section is split into two so that I can remove it without having to lift the spindle up higher along the Z-axis. It simply pulls away like that, and it's held with magnets. At the moment I'm just preparing to surface the wasteboard, and what I need to do is set the tool center to the corner of the MDF material here, which is 47 centimeters across and 42 deep. I have to apologise about the loud fan in the controller. They are small and have to spin a lot faster to shift a large amount of air. There's nothing I can do about it, it's just going to be an annoying sound that you have to listen to, which isn't my voice. So just to mention, I'm using a gerbil controller and at the moment a control software called Candle, which I'll link to in the description. All the actions happening on screen are macros that I wrote in Candle. These are broken down into 4 stages. The first moves the machine head over the probe location. The second probes the tool down in 2 stages to a stationary probe location. The third is used after the probing cycle and offsets the trigger location in the current work coordinate, so the tool tip Z coordinates is set to 0 when the bit is touching the wasteboard. And the fourth moves the machine head so the tool is at X0, Y0 and Z30. That's because I set my job up so the bottom of the material is at 0, which happens to be the top of the wasteboard. And if I move to 0, 0, 0 along all the axes, I'd end up ramming my bit into the material I wanted to work with. So I just had a major boo-boo, and it happened a bit of an unusual way. As I was doing my surface toolpath, I realised that I'd actually orientated the board the wrong way around in the software. So I went to stop the job by pressing the abort button in my software, and the machine just plunged straight into the wasteboard. So there seems to be an issue somewhere. I need to work out where that's coming from. That's really annoying. Going oh so well. Unfortunately, an MDF coloured plaster isn't going to hide my shame, which you all must be blushing about right now. That was a bit unusual. I was really not expecting that. I started to troubleshoot the problem, setting the Z0 height 30mm above the wasteboard and trying different things to stop the job to see if I could pinpoint where the problem was. The controls on the enclosure worked fine, and it turned out to be software. I had accidentally set the control software to Imperial while my jobs were set up in metric. I'm not sure if this happens in all control software, but it's something important to know about. If the cam and control software are not set to the same measurement system, you can expect this behaviour when cancelling a job. Okay, so I pressed the abort button on the software and it literally went cuckoo there. So I amended this and began surfacing my wasteboard again. I'm taking about half a mil off with a 22mm routing bit. After successfully surfacing the wasteboard, I then used my large engineer square to check that the gantry was at 90 degrees to the wasteboard. I'm happy with this, so I can carry on with the next steps, which I filmed as if I'd forgotten all about the things I'd just shown you. So please pretend this is the start of a new video, which I pinned onto the arse end of what you just saw. Okay, in this video I'm going to try and patch up a hole I've made in the wasteboard of my CNC machine. And what I'm going to do is show you all the processes involved in doing this and how I've set my machine up, how it might be different from other ones, and hopefully it'll be quite revealing. I don't normally show all the stages while doing my videos as it's just so time consuming. I have to just assume that you've probably watched some of the older ones where I have revealed something here and something there, and you can just piece everything together yourselves.
To start with, I just wanted to check the machine's squareness before beginning any job, so I did this by cutting out an 18mm disc out of this 12mm MDF, and I used an 8mm cutter to do so. The dimensions are pretty good, which I'm checking with the vernier caliper. It's about 0.2mm off, if that. It's pretty good, especially considering I've just used a ruler to square the machine on either side of the y-axis. Anyway, what I'm going to do now is go through the macros to setting up the machine and actually show you the G-code I'm using, and specifically G-code for the gerbil firmware.
It's not easy to film this, but I'll start by turning the machine on. And before you do anything, after you turn your CNC machine on, you should always home all the axes. And you can do that with a $H command or pressing the home button on your software. Now, I'll make sure that you can see what I'm doing on the software that I decided to use in this instance, and it's called Candle.
And I'm going to start by pressing the home button. So Candle's a little bit like Universal G-code sender, although the interface is a little bit different, and in any case this is what I've decided to use. So something's just gone wrong, because I've got an alarm status there. So I'm going to just unlock that, refresh, and try home again. I'm not sure what happened there. Maybe it was travelling a bit too quick. This is sometimes referred to as a false trigger, but as I've not got a voltmeter or oscilloscope on the sensor while it happens, it's hard to know what causes it. So you need to really look out for the homing cycle and make sure that it actually completes. And the way you do that is you look down at your console to see if there's any messages here, or your status to see if there's any alarms. Now I've created some macros which allow me to use this machine a little bit more quickly, and the first one is a G53 command with a particular set of coordinates which actually moves the center of the spindle above a touch probe. So I'll start by pressing number 1. It's going to move into position, and the next thing is to do a 2-stage probe cycle. So you can see the code popping up there to examine. So it's a G38.4. You've got the speed, which is F500, and then the travel distance, which is -150. Travel coordinates, in fact, as the move is a G90 absolute movement. I'll list my macros in the accompanying article to this video with a bit more of a description as to how they're used. There's a lot of assumed knowledge in this video, but essentially all the G-code functions can be found by searching for one of the many libraries. I particularly like the RepRap one, as it lists all the different flavours of firmware side by side, so you can compare what features are available. But to elaborate, there are 2 types of movements, G90 and G91. G90 is an absolute movement, which means the coordinates refer to a specific location in relation to your home or origin. So for example, if I wrote G53, which is my machine position, and then G0, which will perform a rapid move, if I write the coordinates X0, Y0, Z0, the head of the machine will move to those coordinates, which also happen to be the home position. If I swap over to G91 while in the G54 active work coordinate system, the movement is incremental or relative. The best way to imagine this is as if the current location temporarily reverts to 0 on all the axes, and coordinates have an accumulative effect. So if I wrote G0x-1, the head of the machine would only move 1mm along the x-axis from right to left. G0x1 would move 1mm from left to right. If I want to move 10mm to the left, I would have to send the G10x-1 command 10 times, or write G0x-10. Normally, once you've completed a relative movement, you write G90 to go back to the absolute movement. So the next thing I'm going to do is a G10 command where I set what will be the origin position of all the jobs that I will set up for this machine, and that happens to be in the top right corner of this CNC machine. So different CNC machines work differently. and they will have different locations. The X and Y axis may also be reversed. Now I've already worked out the Z height, which is the difference between the point at which the probe is triggered and the top of the wasteboard after it's been surfaced, so it's nice and flat. And all I've got to do is press macro 3, and now if I press 4 I can move to that location, although I've set it up to move 30mm above the wasteboard so I don't accidentally knock into anything that I've secured down to cut. It actually does a G53 command first and moves all the way up to the Z and then back down. I guess in reality I don't really need to do that, but it gives me a bit of time to kind of just make sure I can see that the machine's working properly. If something slips or something goes wrong with the Z axis, for example, while it's moving up to that position, if it overshoots, it will trigger the Z-axis homing sensor and actually alarm the machine. I'm now roughly measuring the massive gash in the wasteboard so I can cut out a simple shape to cover it. I'm going to pop over to Vectric Aspire software to tool the job. I managed to get a temporary license after meeting the guys at Maker Central 2019 this year. I normally use ArtCam, but that's an unsupported defunct software nowadays, and I've been considering going to Vectrix for a while now. So this is a chance to test the software out, and I'll also walk you through my workflow. Okay, so this is Aspire, and before you start you need to create a new file, and to the left you've got your job setup information that you need to input. This is going to be a single-sided job. Normally what I like to do is set the job size as the wasteboard size, and then I physically move rectangles around to represent the material I'm cutting. So in this case the width is 470 and the height is 420, and I'll be cutting out the disc from some 12mm MDF. I'll make sure I'm in millimeters. The 0 position on the machine is the bed. That just reflects how I set the machine up. Obviously if you'd prefer to work from the top of the material, that's up to you, but I like to work this way because it means I can use my macros that I've just talked about, and I can work in a much quicker way and can do tool changes. And then the other thing that's important is to make sure you set the right datum position or XY datum position. In my case it's the top right corner of the machine, and then we'll ignore the two bottom ones. So I know the size of the material I'm going to be working with. That is going to be 470 wide and 405 deep, and I'm working with it at the front of the machine, so I'm going to snap it to the bottom left edge of the wasteboard, which, if you imagine the coordinates, if the datum position is 00 on the opposite corner of the wasteboard, moving towards the front of the machine and towards the left of the machine means the coordinates go into the negative, so you have minus 470 and minus 420. So apply that, I'll close that. I'm going to make a circle now. I've already got a circle that I cut out, which is about 100mm. I'm going to create that and close it. A nice feature on this is that you can't just simply click and drag the vector files, and the reason I think this is nice is because in ArtCam I've actually accidentally nudged and moved things before setting up jobs and ended up cutting things out with loads of mistakes in them without realizing. So you've got double click, then I can move this around. So I'm going to position this roughly where the other one was cut out. I'm going to also create an offset. Here we go, offset. So we're going to go 8mm offset. That's going to represent the cut line, the outside of the cut line. So now I'm going to do another one, and we'll make that 55 and close that. Double click to move around, and I'm going to do it around there, and I can tell that's going to be fine. Now, so the next thing to do is to create a toolpath. Just going to lock that in place so it doesn't disappear again, and I'm going to do a profile, and I'll just walk you through the things that I'll be setting up. So even though the machine is set up with the wasteboard as 0, as the surface of the wasteboard is 0. In this, it still gives you the option as if the top of the material is 0, and this is just to help understand how you're cutting. This is a little bit different from ArtCam, so it took me a while to get my head around it, but essentially the starting depth is normally 0, which represents the top of the material, and the cut depth is how far you are going down. So if I wanted to go halfway through, I'd change that to 6mm, but I want to go all the way through, so I leave it at 12. Then you've got to select your tool. So I've already created a tool here. I've got my single isolated lonely tool, and I've just popped the window open so you can see the different information about the feed rates and spindle speed and so on. The next thing is the where you're cutting on the vector line. So you've got on the line, inside or outside. We're going to cut on the outside because we want to keep the shape on the inside, and we're going to do a conventional cut. We're going to ignore the allowance offset, which I think is there for wear and tear in the tool. We're going to ignore the next area, then we're going to add a tab so that the disc doesn't move around and get damaged after it's been cut off from the surrounding material. The length is going to be 5, the thickness is going to be 4, and if I click on edit, I have to select the vector and then click on edit tab. I get a new window that pops up, and I can either physically click where I want the tabs to go, which can be a useful feature if you've got a lot more things that you're cutting and you need to think about where the tab will do the most amount of work. But in this case, I'm just going to create 2 and click on add. I'm going to close that. I'm going to ignore the other areas here, so ramping, leading and stuff like that. If the material was a little bit different, if I wanted to kind of maybe produce a slightly cleaner cut, I might use a spiral toolpath. So the next thing to do is just click calculate, and you can see the vectors illustrated by these lines. I'm going to press the play button so I can simulate this, and that looks pretty good. I'm happy with that. I can see my tabs, so I can close this and I can save the toolpath, and I'm using the gerbil post processor in millimeters, so make sure you stick with the same type of measurement system throughout so you don't get the unusual behavior as we saw earlier. And then I can save this.
Okay, that's interesting. The spindle stopped very quickly there. When I've used ArtCam before, the spindle would still be spinning while it's moving back to that datum or origin position, and it would only stop spinning once it got there. So that's a nice feature. Got my mad sharp chisel. Okay, that looks really good, really round, and again it's pretty bang on. That's exciting. Okay, now I can take this off and try and perform a cutting job where I can pop that in and glue that in place. I made it a long time ago before I started making CNC machines. I wasn't particularly accurate.
I can now place the puck on the wasteboard and measure in from the datum or origin position. I use those measurements to lay out the circle in the software, which I also offset to make the new opening a tad larger than the puck I've just cut out, maybe 0.2 millimeters. Now I can go to the edit drop down menu and select job size and position. There I can change the 0Z position to the material surface so the cut will go into the wasteboard without me having to change anything in the control software. I press OK to update the new job conditions, but receive a warning message because I hadn't deleted the old toolpath. Once that's deleted, I can create a pocket or area clear toolpath. I'm going to start the cut at 0mm and cut down to 10mm. I used the same 8mm tool as last time with the offset and conventional clearance type. I avoid all the other variables and press calculate, simulate the toolpath to check for any errors, and then save the G-code file with the gerbil post-processor. I open up that file in the Candle control software and run the job. It's scary cutting into your own wasteboard, but at least this time I'm doing it on purpose. The moment of truth, and it fits, and I can even rotate the puck around, which is a sign that the shapes are not elliptical. I can now glue the piece in place, which I do upside down so the tabs are above the surface of the wasteboard. I'll leave it to dry for a few hours and then surface it down. I do this a little bit at a time using the same methods as you saw earlier. Alternatively, I could have just surfaced the entire MDF wasteboard in one go. Surfacing the wasteboard every time it gets scuffed up keeps the cutting tool travelling parallel with the material you're working with. It's an easy way to level the Z-axis without using overcomplicated bed leveling matrices, and you also save a bit of money in the process. So I hope you found that video interesting. Please let me know if you use your CNC machine in a different way, and if there's any particular topics you'd like me to go over. I've been busy building a new CNC machine and learning how to use the Duet 2 Wi-Fi for CNC control. I've got lots of pictures and videos on my Instagram account, and if you want to see what I've been getting up to, you can find me in the link provided. And that leaves me with the last thing to say, which is pay homage to the algorithm gods. You know how to do it.